Hey, and welcome to the second part of functions. We just got to talk about compositions of functions, which is really related to inverse functions. Starting with compositions is just when we shove one function into another function. We can do this with variables, or we can do this with numbers, either way. We start out with this middle piece and we figure out, okay, well, what is f of 0? Well, that's 0 plus 1, so that's just 1. And then you figure out, okay, well, what's g of 1? Well, then you shove a 1 right here, and 1 minus 1, that's just 0. If you want to check out the other ones, check out the PDF notes. Maleficent is happy to help us out, aren't you? Say hello to everybody. Hi! All right, next thing, we're going to look at a little bit more interesting functions. So for these ones, going to hop to our perch maybe? Maybe yes, no, maybe so? That's okay. I mostly just need you to look at stuff right now. So I graphed f of x and g of x. We want to figure out what would happen if we put these functions into each other. Cool thing about Desmos is it'll do that for you. So here I've got g of f of x. I'm going to get rid of those other two. She's off to her perch now. And it turned out to be this straight line. Okay. What about if we do this the other way, f of g of x? Hey, that's also just a straight line. Oh, what cool things. So it's turning into just being x. When you mesh them together in a composite and they spit out just an x, that is a sign that they are an inverse function. In order to have an inverse, you first need to be a one-to-one function. What these are is it's a function that you put one thing in, you get one thing out. But to get that thing out, there's only one way to get that thing. So we use the horizontal line test. So here's a couple functions, and we're curious, hey, are these one-to-one functions? Reciprocal is a tricky one. It seems like it's not going to be a one-to-one function. Like you're a little worried right here, but it actually doesn't exist at that point. So this one is a one-to-one. This other one, however, is not, because it is a good function. If you pass a vertical line across it, it will only ever touch it once. However, it does fail our horizontal line test. So this is not a one-to-one function. Since it's not one-to-one, that thing has no inverse. This one does have an inverse. Check to see if two functions are inverses. Do the compositions in both directions. If it works in both directions, then it is an inverse function. To find it, you swap x and y, which is an illegal math move, but it's how you create an inverse, because you're making a new function that's the inverse of the original. You solve for y, and then this is our notation for inverses. It's f to the negative 1. So we want to show that f and g are inverse functions, and we're going to do it in a few ways. We're going to do it analytically, we're going to do it numerically, and we're going to do it graphically. Let's start with A, analytically. We're going to do another one of those compositions of functions. So I'm going to start with f of g of x. So I'm going to put g into f. So that is, if I draw f, 1 over 1 plus, and then we want to put g of x in that x spot for x. So this little thing right there, we want to put g of x right there. To simplify this thing, I'm going to multiply top and bottom by x. In the denominator, that two x's, they cancel each other out. So we get x over 1, which is just x. So sweet. Now we got to check it the other way because it's got to work both ways. We're going to do g of f of x. So we're going to do g in green. So we've got 1 minus, we're going to have to put a thing there, over somebody else. And that thing that we're going to have to put there is f of x, which is 1 plus x, 1 over 1 plus x. And then we'll put that same thing in the denominator, 1 over 1 plus x. We're going to do the same sort of solving step. We're going to multiply top and bottom by 1 plus x. So we end up with 1 minus 1, that's 0, x over 1. Since those both ended up equaling just x, those two are inverses of each other. We have shown that analytically. If we wanted to show it numerically, we would pick a number. Let's do 3. That's what I'm going to use. So I want to figure out what f of 3 is. So that's 1 over 1 plus 3, which is a quarter. Okay, great. Now, if it's an inverse, I should be able to do g of a quarter, and this should equal 3. So I get 1 minus a quarter over a quarter. So that's 3 quarters, and I'm going to multiply by reciprocal. So 3 quarters times 4 over 1. Hey, that's 3. Sweet. So since I was able to put in 3 and I got 1/4, and we did 1/4 and we got out 3, that's doing that numerical check. Our last one is we want to graphically check to see if these two things are inverses. See how this point right here is hopping over and going to that point. See how this one right here is kind of hopping over and going to that one. This point where it's going through the line y equals x is just going nowhere. So it is doing that nice reflection across that line. It's kind of tough to see. All right, now what if we wanted to find an inverse? First thing we do, we replace that f of x with a y. And we're going to swap x and y to make a new function, the inverse function. In order to get it by itself, we got to square both sides. And so we get y equals x squared. So f inverse of x is x squared, which you think is just going to be a quadratic and it's going to have the full u, but it's taken from this square root function. So the information from this is not lost when it moves over to this other one. X squared is not a one-to-one function, meaning that it does not have an inverse. However, square root is a perfectly good one-to-one function, so it does get an inverse. In order to make sure that these two are working together, we need to create a function similar to what we had before, where it ignores this piece of the graph. We shouldn't have that part. You can actually do that on Desmos by doing a little curly bracket and then saying, hey, x has to be greater than 0. And then it will only do that point. So we need to include that in our function. And it's actually greater than or equal to. So the relationship is they're reflected over the line y equals x. The domain and ranges. So for f of x, its domain and range is it goes from 0 to infinity, and the range also goes from 0 to infinity. Oh, those are supposed to be hard brackets. Hard bracket? Corner bracket? They shouldn't be parentheses, is what I'm trying to say. Same thing is true for the inverse, but it would be these two swapped around. However, they're the same thing, so you don't get to see anything crazy happen. So that would be the domain and range of our inverse, and in green we have our domain and range of our original function. So compositions of functions, that's putting functions in functions, cats on cats on cats. Thanks.